Hey guys, it's Mr. Ross. Last Friday we had a short amount of time to go over how to do these LOL charts or the energy bar charts. I just want to take a couple minutes just to review how to do some of those through a problem that kind of takes a look at the same example through different systems. Before we do that, I want to remind you these are all about energy conservation. These problems and even the energy pie charts that we did, they're just helping you figure out how do we conserve energy. The concept here is energy is not disappearing. It's not magically happening. It's being added or subtracted from the system. Now, in the past with the energy pie charts, if you have energy that leaves your system, then technically what we should have done is we should have had our next pie get smaller. Okay, if energy is added to our system, then we should do the reverse of that, which is make a bigger pie chart. Okay, with the LOL charts, we have a little bit of a different way of doing things. So we're going to look at that problem that has the spring. Okay, so we have the car, does the loop. We're looking at it up here. We're looking at it over here, and we got the spring. Okay, so this is the system. We're going to include the cart and the track and the spring this time. Okay, so if you do your bar charts, okay, in this case we start out at position A with all of our energy in the elastic energy. So we can just write PE elastic and 100% of our energy there, or remember we're doing like the 4 lines. Okay, all the way up to elastic potential energy. Now if we go over and we look at position B, I should have put some little parts like that. It's moving, so we're going to have some mechanical energy. So we'll have KE mechanical. We're also going to have some potential energy because it's above its highest point on the tracks there. So, okay. Now, I'm going to say that most of it is mechanical energy. You guys can split it up however you want. So I'm going to make it go up to 3 for the mechanical energy. And again, these are qualitative, so you can do it however you want. And then the remaining 1 is, okay. This central one right here, notice that I didn't really have to do anything to it, okay? This central piece for the pie chart, this is to show whether energy is coming into the system or whether energy is leaving the system. And we're going to show you how to do that in just a second, okay? So for this would be the correct one if my system includes the spring, the car, and the track. So let's take a look at this in a little bit of a different light, though. This time, I'm going to make the spring not be part of my system. Okay. So at the beginning here, if the spring is not part of my system, then I don't have any energy in my system. I don't have gravitational potential energy because it's at its lowest point already. I don't have any mechanical energy because it's not moving. So I really don't have any energy to speak of in this case. So my first bar chart is not going to have anything on it. So for us to do any kind of motion or work or anything like that, we've got to have some energy. So in this part, we have energy that enters our system. And we're going to do that by showing a big arrow. Okay. Now that arrow, I'm going to split up. If we had the 4 little levels on here, okay, then if we're going to add energy to the system, let's just make it 4 boxes worth of energy. Okay, so 1, 2, 3, 4 boxes there. Okay, so we have energy that is entering our system, and this is, if we wanted to label it, and you don't necessarily have to, this is the elastic potential energy that's entering our system. Okay. So now over here, we have energy that has gone into our system. Okay. So it's kind of the same as last time. We have some mechanical energy, so We also have some gravitational potential energy. Okay? And I'll just split them up the same way I did last time. Remember, it's qualitative, so you can kind of do it however you want. But notice that I have 4 blocks over here. I've got a total of 1, 2, 3, and then a 4th block right here. This is all about conservation of energy. So I haven't lost any energy in my system. Everything is still there. We added energy from the system. Okay, so at first here we didn't have any energy. Added 4 pieces of energy, or 4 units of energy, and we end up with 4 units of energy. Okay, we're going to do this one more time, except this time the only thing in our system is going to be the spring. Okay. Now, if you wanted to, you might stop the video right now, try and do this one before I show you the answer, but we're going to just make the spring the part of the system and everything else not part of the system. Okay. So, if I have the spring and that's the only thing in the system, it's going to have, at the very, very beginning, elastic potential energy. So I'll put PE elastic. And I'm going to say that it's fully elastic potential energy. I don't see any other types of energy in there. So we're going all the way up there. Okay? Now, once we let go and everything is kind of moving through here, there's no more energy in the spring. So we have energy this time that has gone out of the system. Okay? And we're going to make that 4 units of energy because that's what we had. We had 1 block, 2, 3, 4. So I'm going to make it 1, 2, and then 3 and 4. So I got 4 units of energy that are leaving the system. So now over here on this one, we actually don't have any energy that is in our system anymore. So this is kind of the solution for this one. Now as you go through all these, remember, if we have energy that is entering our system, then we'll have an arrow going into our kind of pie graph here. If we have energy leaving the system, opposite. If the system includes all the objects and we don't have any energy coming in or going out of the system, then we don't have anything really we have to do with this pie. But remember, at some point in here, you've got to account for all the different units of energy. If we started out with 4 and everything in the system, there's no energy being added to it or subtracted from it, then we're going to end up with 4. Okay, they're going to be kind of divided up differently, but everything has to be accounted for. This is a conservation of energy problem. That's the main point of this. So, if you guys have questions, come to me during class. This was just a small example, so obviously I won't be able to help you with every piece of the homework, but just come ask if you guys need any help. So yeah.